video, we are going to attempt past paper free response questions related to calorimetry. So first question is, a student heats 40 gram of water in a calorimeter. The temperature increased from 21 to 24.5. The specific heat capacity of water is 4.18 joules per gram per Celsius. They want us to calculate the temperature change. So we can calculate the temperature change by just subtracting the final temperature minus initial temperature. So this is final temperature and this is going to be initial temperature. You can subtract them and the answer comes out to be 24.5 minus 21.0, and that is 3.5 degrees Celsius. Then in the next part they are saying calculate the amount of heat absorbed by the water. So the heat absorbed by the water we can calculate by the formula Q is equal to mc delta T, where m is the mass of water, that is 40 gram, and C is the specific heat capacity, that is 4.18, and temperature change that comes out to be 3.5, and the final answer that comes out to be 585.2 joules. Then state whether the heating of water represents an increase or decrease in the energy of the water. So the heating of water represents an increase in energy of water because Q is positive, showing that the water absorbs energy. So how we are going to write it, as it is for 2 points, that increase in the inner, it represents the heating of water. Heating of water represents an increase in the energy of water, in energy of water. What is the reason? The reason is that as Q is positive, if Q is positive, then it represents that there is an increase in the energy of water, and which shows that water absorbs energy. Water absorbs energy. In the next question, they are saying the two samples of water are mixed together in an isolated calorimetry. 20 gram of water at 18 degrees Celsius, and the next one is 30 gram of water at 26 degrees Celsius. So this is at high temperature and this one is at low temperature. In the question they are saying assume no heat is lost to the surrounding and that the specific heat of water is 4.18. State which sample of water cools during the mixing. So sample of water which will cool during the mixing is the one which is at high temperature. Definitely heat is transferred from high temperature to low temperature. So we can write here the sample at 26 degree Celsius. Write the expression for the warmer sample using Q is equal to mc delta T. As we know that first of all, this is basically at high temperature and this one would be the more warmer. So if we are going to write the expression for it, it will be Q is equal to mc delta T, where delta T represents the change in temperature from final temperature to initial temperature. So we can write this expression as Q is equal to M is the mass, which is 30 gram, C is the specific heat capacity of water, which is 4.18, and delta T is going to be T final minus initial, which is going to be 26 degrees Celsius. So this is the expression which we are going to write out here. Write the heat expression for the cool sample. For the cool sample, it is going to be Q is equal to 20, because the cooler one is having 20 gram. So 20 gram times with 4.18 times with T final temperature minus initial temperature, that is going to be 18. Use energy conservation, state the relationship between heat loss and heat gained. So we know that heat lost equals the heat gained by the other sample. We can write it in this way, that with no heat lost to the surrounding, any heat lost by one sample must be gained by the other sample. So we can write this one as Q hot is equal to negative of Q cold. And when this minus comes on that side, this one would become Q hot plus Q cold. That one would be equal to 0. So in this question, aluminium metal can be recycled from scrap metal by melting the metal to evaporate impurities. Calculate the amount of heat required to purify 1 mole of aluminium at 298 Kelvin by melting it. The melting point of aluminium is this much, and its molar heat capacity is 24 joules per mole per Kelvin, and the heat of fusion is 10.7 kilojoules per mole. So if we want to calculate it, we first need to calculate the amount of heat needed to raise the temperature of aluminium to 933 Kelvin. How we are going to do that? First, the original temperature was 298, and first we need to find out the difference. So the difference of temperature is 933 minus 298. That comes out to be 635 Kelvin. And our first thing is to find out the heat needed to raise the temperature of aluminium to 933 Kelvin. How we are going to do that? We are first going to multiply this molar heat capacity, 24 joules per mole per Kelvin, and we need to multiply it with the number of moles. There are 1 mole, and then we need to calculate multiply it with the temperature change. Temperature change is 635, and the answer that comes out to be is 15,000 joules. And first we have to convert it into kilojoules. That is 15 kilojoules by dividing by 1000. And now what we need to do, we are going to add the heat of fusion. This is basically heat of fusion. Heat of fusion is the heat required to melt 1 mole of the substance. So this is heat of fusion, and then I'm going to add the previous one, that is heat of fusion at 10.7. I'm going to add them together, 10.7 plus 15, and the answer that comes out to be 26 kilojoules. The equation for the overall process of extracting aluminium from aluminium oxide is shown, which required less energy: recycling existing aluminium or extracting aluminium from aluminium oxide. So you can see this enthalpy change is for 2 moles of aluminium. So 2 moles of aluminium are giving us this much energy, 1675 kilojoules. And for 1 mole of aluminium, what we need to do, 1675 divided by 2, and the answer comes out to be 837.5 kilojoules. Then afterwards, we can see one thing. This is the energy of extracting aluminium from Al2O3, but this energy 26 kilojoules, as you can see that 26 kilojoules is less than 837.5 kilojoules. So recycling would, you can see that recycling requires less energy. In this question, they are saying that a student performs an experiment to determine the enthalpy of combustion of 2-propanol, which combust in oxygen according to the equation above. The student heats a sample of water by burning some of 2-propanol in an alcohol burner, that is in an alcohol burner as represented below. So this is 1-propanol, and the mass of propanol combusted is determined by weighing the alcohol burner before and after combustion. So this is the data which has been given. This is the mass of 1-propanol that has been burned. This is the mass of water that has been heated, and this is specific heat of water. These are initial and final temperature. So they want us to calculate the magnitude of heat energy. So how we can do that? We know Q is equal to mc delta T, where m is the mass, m is 125, which is the mass of water, times it with specific heat capacity 4.18. Delta T is the difference between final temperature and initial temperature, and that comes out to be how much? That comes out to be 15,200 joules, which is equal to 15.2 kilojoules by dividing by 1000. So now they are saying, based on the experiment above, if 1 mole of propanol is combusted, how much heat in kilojoule is released? For that purpose, you need to first calculate the mole of propanol, C3H7OH, that is equal to mass divided by molar mass. Mass is how much? 0.55 divided by molar mass of propanol is 60.09. And now we know for combusting 1 mole, what we need to do, we are going to do 15.2 kilojoules, which is the heat, divided by the mole of propanol, that comes out to be 0.55 divided by 60.09, and the answer comes out to be 1661 kilojoules per mole. Part, second student performed the experiment using the same mass of water at the initial temperature. However, this time the student uses an alcohol burner containing C3H7OH that is contaminated with water. So now the alcohol here, that is going to be contaminated with water, means water has been added into it. And now he is asking, contaminated with water, and you know water and alcohol are miscible. Okay, these both are miscible. Miscible means that they both can be dissolved into each other. So he is asking that the difference in mass of alcohol before and after the combustion in the experiment is also 0.55. So the mass of alcohol and water that has been burned, and after that the mass which has been left is also 0.55. So he's saying that would the final temperature of the water in the beaker heated by alcohol burner, now alcohol burner, as we know that it contains water as well as alcohol. So he's saying in this experiment would be greater than or less than or equal to the final temperature of water. So definitely it is going to be less than water. Why? Because now water has been added into the fuel. So you can write here that if there is a combination of water and fuel, so you can say that it is going to be less than the mass measured by first student. Why? Less than the mass measured by first student, or less than the temperature measured by the first student. Why? Because the actual mass of C3H7OH combusted will be less than 0.55 gram. Why less than? Because now it's mixed with water, so water has also been burned inside it. So in this question they are saying a student investigate the enthalpy of solution for two alkali metal halides LiCl and NaCl. In addition to the salt, the student has access to a calorimeter, a balance with a precision of plus minus 0.1 gram, and a thermometer with a precision of plus minus 0.1 degree Celsius. To measure enthalpy of solution, the student adds 100 gram of water, initially which was at 15 degrees Celsius, to a calorimeter and adds 10 gram of LiCl, stirring to dissolve. So what he is doing, that before the mass was 100 gram and now the total mass after adding LiCl becomes 100 plus 10 is equal to 110 grams. So now he's saying the temperature, final temperature, initial temperature was this one. This was initial temperature. And then it raises, after mixing, it raises to 35.6. So that is final temperature. And now they are saying calculate magnitude of heat absorbed by the solution. So if we want to find that, Q is equal to mc delta T. M is the mass, which is 110 grams times with specific heat capacity, which is 4.18 for water, and delta T is going to be 36.5 minus 15.0 degrees Celsius. So one thing here that it comes out to be 9470 joules, and that is 9.470 kilojoules. Now they are burning, like they are dissolving 10 gram of LiCl. So first we are going to find the moles. Mass is how much? 10 grams, and molar mass of LiCl is 42.39. So it comes out to be 0.236 mole. And one thing, this this value, which is heat, is basically referred refer to the system, not the surroundings, so it is going to be negative. Why? As this heat has been released, minus 9.470 kilojoules, and you know Q is equal to delta H is equal to Q divided by N is the number of moles, so Q is minus 9.470 divided by 0.236, so it comes out to be minus 40.1 kilojoules per mole. In this question they are saying write the complete electronic configuration of sodium ion in the ground state. So sodium ion is Na plus, which means it has 10 protons. And now, so Na positive contains 10 protons, 10 electrons, because it has lost one electron, and its electronic configuration is going to be 1s2, 2s2, 2p6. Use principles of atomic structure why sodium ion is larger than Li positive. Li positive has 1s2 as its electronic configuration. So as you know that the valence electron of sodium ion is at higher principal energy then valence electron in Li positive ion. So electrons in higher principal energy levels are, and they are on average further away from nucleus. So the one which is having higher principal energy level, that would be further away from nucleus. Which salt, LiCl or NaCl, has greatest lattice enthalpy? So as we know that lithium is present above in the group and it is going to have small size and it is going to have greater size. So what happens that as Li positive, as which salt, LiCl or NaCl, has greater lattice enthalpy, so that is going to be LiCl. Why? Because Li positive ion is smaller than NaCl. Na positive, we can say Na positive ion so the Coulombic attraction in LiCl are stronger than NaCl, and that is why it has greater lattice enthalpy. So LiCl would be having greatest lattice in the enthalpy. So in the next question, below is the representation of a portion of crystal of LiCl. Identify the ions in the representation by writing the appropriate formulas Li positive or Cl minus. So as Cl minus has 18 electrons, so we know that it is having greater shell. It is having greater shell and radius of the ions. So it is going to have more electrons. So you can see the one which is having a greater shell, that would be chloride ion, and the one which is having a smaller shell, that would be Li positive. We also need to write this reason that chloride ions have more electrons than lithium ions, so increasing the number of shells, and therefore the radius of ions, and therefore the radius of ions. So the lattice enthalpy of LiCl is positive, because what happens in lattice enthalpy, the bond has been broken. When the bond has been broken, this process is endothermic, and delta H is positive. Why endothermic? Because bond is breaking and is going to form Li positive gaseous state plus chloride negative in gaseous state. Then what happens further? There is a force of attraction that has been developed between Li positive and oxygen. You know, oxygen is having negative dipole and this is having partial positive. So this force of attraction that has been developed here is ion dipole attraction. And this ion dipole attraction that is developed between ion and the dipole, so we can write here that there are interactions between lithium ion, Li positive ions, and polar water molecules, and between chloride ions and polar water molecule. This is for 1 mark, and in the second mark you can write that this is ion dipole interaction. In the next question, they are saying a student performs a calorimetry experiment to measure the enthalpy change for the dissolution of potassium chloride in water. The mass is given, initial temperature is given, and the final temperature is this much. So you can see the final temperature drops. So definitely the process is going to be endothermic. And if we are going to find out Q is equal to mCp delta T, where m is the mass, that is 100 gram of for water, c is the specific heat capacity, and delta T is going to be 21.5 final temperature minus 25, so that comes out to be minus 1463 joules, and this process is endothermic. So when Q is negative, the process is endothermic. Determine the enthalpy change for dissolution of 1 mole of potassium chloride. So mole is equal to how much mass has been given, that is this much. So first calculate the mole, mass over molar mass. Mass is 5 gram and molar mass is 74.55 for potassium chloride, and the answer comes out to be 0.0671, and delta H is going to be minus Q over N, and that is going to be how much? That is going to be minus 1463 and divided by 0.00671, that comes out to be 21,800 joules per mole, and that is 21.8 kilojoules per mole. Explain why a polystyrene cup is often used as a calorimeter. Because it minimizes the heat exchange with the surrounding. In this question, they are saying determine the oxidation number of chlorine in NaOCl. So how you can do it? You can just keep it is going to be total oxidation number is going to be 0. So for sodium is +1, for oxygen is -2, and for chlorine we need to find out, and we are going to keep it equal to 0. So -1 plus Cl is equal to 0, and Cl comes out to be +1. So in this question they are asking about us to calculate the number of grams of sodium sulfide. So how can we do that? First convert this 100 milliliter into liter, that is 0.1 liter, and this one is 0.5 molar. Molar represents mole per liter, and the formula to find the mole is what? That is going to be concentration times volume, and then we have to find out mass. So a mole is equal to mass by mR, and mass is equal to mole times mR. So what does it become? Putting this value of mole, that becomes concentration multiplied by volume multiplied by mR. Concentration is 0.5, volume is 0.1, and mR is going to be how much? mR is going to be 158.10, and the final answer that comes out to be is 7.90 grams. In this part they are saying use the balance equation for oxidation reduction reaction, and the information in the table above determine which reactant is the limiting reactant. So first let's find out the number of moles, because concentration and volume are same. So 0.5 times 0.005, as it is in milliliter we have to convert it into liters, and the moles are same for everyone, 0.0025 mole. Now what happens there? That look at the coefficients. If you look at the coefficients, like 4 sodium, like this NaOCl is reacting with 1 mole of sodium sulfide and 2 moles of sodium hydroxide. So what we can see that 4 mole of NaOCl are needed for every 1 mole of Na2H2O3 and 2 moles of NaOH. So what is going to happen? NaOCl will therefore run out first, and it is the limiting reactant. So how can we write here that we can write that as 4 mole of NaOCl will react with 1 mole of Na2S2O3 and how many moles of NaOH? 2 moles of NaOH. So what is going to happen out there? So NaOCl will run out first. So it is a limiting reactant. So this one is going to be, so NaOCl will be limiting reactant. So according to the graph, what is the temperature change of the reaction mixture? So this is about 32.5 and this place is 20. So the difference of them is 12.5 degree Celsius. So in this question they are saying calculate the magnitude of heat energy, and we are given with the mass and the specific heat capacity. So formula is going to be Q is equal to mc delta T, and it comes out to be how much? Mass is 15.21, C specific heat capacity 3.94, and delta T is how much? That is 12.5 we have calculated here. So it comes out to be 749 joules. And then they are saying in the next question, use the balance equation for oxidation reduction reaction, and your answer to part C, calculate the value of enthalpy change for the reaction. So first what we are going to do, we have found the number of moles of NaOCl before, because we know moles are same, that is 0.0025 mole, 0.0025 mole. And then what happens, like we know that for NaOCl you can see one thing, there will be 1 mole of reaction, okay, RxN, that contains how many moles of NaOCl? 4 moles of NaOCl in the reaction. Okay, so you can see one thing, that what is going to happen, like mole of NaCl, that would comes out to be divided by 4, 0.000000625 mole of reaction, Rxn. And then we have to find out the enthalpy of Rxn, that comes out to be this is 749 joules, and as we know that we have to convert it into kilojoules, that is 0.749 kilojoules. And one thing here, that we are going to put minus sign here because it is exothermic, so minus 0.749 divided by 0.000625. So the final answer comes out to be minus 1.20 times 10 to the power of 3 kilojoules per mole of reaction. So now they are saying that the volume gets doubled. So if volume gets doubled, calculate from the result of second experiment is the same as the result calculated in part E2. Explain this result. So what happens that by doubling the volume, you can say by doubling the volume, what has happened here, the mole of reactants are also doubled. The mole will be doubled as well, because you are multiplying it, the mole will be doubled. And if moles are doubled, and it will which double the amount of energy produced, amount of energy produced. So what is going to happen there, like enthalpy of reaction, now you know mc delta t, so it would, this one would become 2 mc delta t, because heat is also doubled, and 2 moles like moles are also doubled, so they would be cancelled out, so the answer would remain the same. So we can say the magnitude is same as calculated in the first experiment. Now they are saying write the balanced net ionic equation for this reaction. So you have the reaction that is going to be the reaction, first write the reaction for it, and that one is going to be Na2S2O3 plus 4NaOCl and plus 2NaOH, and what they will produce, they would be forming 2Na2SO4 plus 4NaCl plus H2O. So writing the ionic equation, we know this is in aqueous, this is in aqueous, this is also in aqueous, and this is aqueous, this is also aqueous, and we know for writing ionic equation only aqueous form will break. And how it is going to break, let's see. It is going to produce 2Na positive aqueous plus S2O3 minus 2 aqueous plus we have 4Na positive aqueous plus 4OCl minus aqueous plus 2Na positive aqueous plus 2OH minus aqueous, and they would be forming what things, they would be forming 4Na positive, because this is 2, this is multiplied with this 2, 4Na positive aqueous plus 2 sulfate ions in aqueous form plus 4Na positive in aqueous form plus 4 chloride ion in aqueous form, and then we have water molecule. We are going to write it like this because that is in liquid form and that will not break. So on the left hand side, first of all, let's see Na. Na, there are 8 Na. Add them and they would be cancelled with the Na there. And when we are going to see the other thing that would be cancelled here, that would be, yeah, just this much is cancelled because all other are different. So final ionic equation become S2O3 minus 2, and we have 4OCl minus in aqueous form, plus 2OH minus in aqueous form, and they would be producing what? They would be producing 2 sulfate ions in aqueous form plus 4 chloride ion in aqueous form plus water molecule in liquid form. That will be the final thing that would be formed here.